Hi student, today we shall discuss again another important topic that is called spherical polar coordinate system. Spherical polar coordinate system has been considered to be very important topic in physics as well as in mathematics as well as in mathematical physics. So in physics we use it in heat and thermodynamics, electrostatics, electrodynamics, again quantum mechanics, mathematical physics. There are a lot of branches where we use this spherical polar coordinate system. Now the thing is, the main problem with this spherical polar coordinate system is to visualize the angle r theta phi, what we consider this r theta phi. We understand what is xyz, but when we are to convert this xyz to r theta phi, then we face some problem in visualizing. This is my experience from the student side. The main difficulties lies in the fact that we draw a three-dimensional object or a three-dimensional sphere in a two-dimensional plane like board or in a plane of paper. So that's why it becomes difficult for us to visualize the thing. So today we shall discuss how to visualize this Cartesian three-dimensional coordinate system xyz and how to transform from xyz to r theta phi, and we will get the relation between r theta phi and this Cartesian coordinate system xyz. So we will go again with pen and paper and then show with a sphere how this r theta phi is related to xyz. So before we enter into this 3D spherical polar coordinate, let us first understand the 2D Cartesian coordinate system, Cartesian coordinate system in 2 dimension, as well as the 2D another coordinate system that is called your polar coordinate system. So this is represented in r and theta, and this is represented simply in x and y. Now if you consider any point in a Cartesian coordinate 2D, then suppose this is the point P we are to represent in two-dimensional space. Then what you have to do, you have to move along the x-axis first up to this point, and then you have to move up to along this y-axis. Okay, so if you are to represent, so this is the point R, this is the point P, and from the origin it is at a distance r, then along x-axis this will be your x coordinate, this will be your y coordinate, and that's why we write pxy. Now you see y is always rectangular Cartesian coordinate system, it is perpendicular. So using Pythagoras theorem I can write here r square is equal to x square plus y square, or r is equal to root over x square plus y square. That way we represent it. Then in polar coordinates, same point, suppose this is, you consider a point P, what you can do, you can use another coordinate instead of x and y if it is your r. Then if you consider this angle theta, then for different points, suppose P is here, then your theta will be different. Okay, so by representing, and if P is here, then r will be different. So you can use r and theta also as the variable to represent any point in this 2D. So in that case, if I draw another perpendicular, this is your x-axis, this is y-axis again. This is r, this is theta. Mind you, this is in the anti-clockwise direction from the x, because if you consider clockwise, then this will be your angle. Okay, so this angle. In that case, if you consider, say, give a name OPC, then from this triangle OPC, what you get? Cos theta is equal to base by hypotenuse, so OC by OP. So OC is equal to OP cos theta. That means OC is what? Along the x-axis I will consider x, and OC is x, OP is r. So I can write x is equal to r cos theta. Similarly, if you consider this sin theta, then what we get? We get this perpendicular by hypotenuse. That means PC by OP. So PC is equal to OP sin theta. Okay, so ultimately PC is what? You draw a perpendicular. PC is nothing but y. PC is equal to y, and OP is r, and this is sin theta. So that's why in polar coordinate what we write? We write x is equal to r cos theta, y is equal to r sin theta. Is it okay? Now let us move this two-dimensional space to three-dimensional extension. You extend it towards 3 dimension. Okay, this is your rectangular Cartesian coordinate system in x, y, z. Now instead of this xy plane, I have considered the xy plane is here. Same thing, this is your x-axis, this is your y-axis. Same thing I am writing here, x and y. Okay, for the first time you leave it. This is the xy plane, so this was your xy plane. Now you are to represent a point, any point, say point P. In xy plane, of course, the coordinate will be again xy. So what you have to do, you have to first move along the x-axis, then you have to move along the y-axis. Okay, so x-axis, y-axis, y was perpendicular to this, so this is also perpendicular to this. Though in this diagram you don't see it as a perpendicular, but it is perpendicular. Okay, same thing I am drawing here. So in that case, if I consider from O, I am considering, say this is your distance rho, because I have to consider z axis also, then I will consider r. Now I have used another symbol rho. So this point is again x, this point is again y, same thing here. Then of course you can write rho square is equal to x square plus y square. This is the two-dimensional plane, same plane here. Now if you are to represent in the three-dimensional plane, this point is not sufficient. Suppose this is the axis here, this is x-axis, this is y-axis, this is the z-axis. Suppose a point is here. If you move along x-axis, you will get this point. If you fix this y-axis, then you will fix this point. Okay, you are getting this point, but this point can be anywhere along this line. So you need to fix this z-axis also. So what you do, you draw a perpendicular from x-axis, you draw a perpendicular from y-axis, and then you draw a perpendicular from z-axis. As a result, you get this point P, x, y, z. So to represent a point here, you need to draw a perpendicular, what we call the z-axis, and this is most of the time we call it as a projection. Now if you were to represent this point here P, this is now x, y, z. You are considering the z-axis also. Here it was only xy plane, now you have considered the z-axis. This is again perpendicular, this is again rho, so this is the hypotenuse. So if I consider this is r, then this will be r square is equal to rho square plus z square. Again rho square is equal to x square plus y square, so I will write r square is equal to x square plus y square plus z square in 3D Cartesian coordinate system. So this is just, we have extended from Cartesian coordinate 2D system to a 3D system. But when we draw simply like this, then it is very difficult for us to understand the thing. What we consider, suppose you consider this is I have considered a book as the rectangular object. You can visualize the thing like this. So this is x-axis, this is y-axis, and this is your z-axis. Along this is your z-axis. Now what you can do, you can vary along x-axis to get the whole book. That means if you cut along x-axis in a symmetric way, you will get the whole book. If you cut along y-axis also, you will get the whole book. And if you cut into some slices like this along the z-axis, then also you will get the whole book. So what we can visualize that these x, y, z are three variables which when changed we get the object. Now we will consider, or we will extend this polar coordinate to 3D made of some concentric spheres. Then the picture will be something like this. the picture will be something like this. Okay, if you consider this a small apple, this is a bigger apple, then it is a bigger apple, then it is a bigger apple. That means changing the radius symmetrically, you will get the whole apple, whole sphere. Okay, then what are the other variables you can get the whole apple? How can you change the other variables to get this whole apple? In that case, what you can consider? You can consider that you can cut this apple into slices like this, okay, along this axis, along this direction. If I cut into some vertical slices, then I will get the whole apple. But once you cut in this way, after this half of the hemisphere, you will see that this is symmetric. This part and this part is symmetric. So if you change the variables, or if you cut up to this point and then you repeat it, you will get the whole apple. Getting my point? So what we consider, these slices, if I cut into this type of slices, then I will get this type of slice. These are some slices. This is first slice, second slice, like this. If I cut into this, now you see the angle made by these slices at the origin, okay, and this is your z-axis. So this angle, this is also symmetric. This part and this part is symmetric. So this angle with this axis, if you consider any point, okay, then this is of course radius, these are radius. So this point, this angle, we call it a polar angle or theta. So if you vary this theta, then you see you will get up to this point. This way you will get the whole slices. So if you vary the theta from 0 to pi, then you will get the repetition. After pi you will get the repetition. So by changing the variable of theta from 0 to pi, we will get the whole apple. So this part is called polar angle. We will use theta as the variables. Okay. Now again another cut of apple, what you can do, you can cut this apple into this type of pieces also. What we generally do, do you cut this like this, okay. These are some pieces, okay. In that case, what we will see, you will see that if it is your z-axis, okay, then this is an angle, this is another angle, okay. So this angle we represent by this is my slice, so this is the angle, okay. You consider this is the slice, this is my angle. So this angle, when you change this angle, we will consider as the azimuthal angle or phi. When you change this phi from 0 to twice pi, 360, I will get the whole apple, full apple, by changing this phi. So this angle we will consider as the phi, okay. So as a result, what we have got, three variables for this sphere. That is, one is your r, another is your theta, polar angle, another is your phi. So first we have to understand why r, theta, phi, because by changing the r you can get the whole sphere, by changing the theta you can get the whole sphere, by changing the phi you can get the whole sphere. Now the thing is, what is the limit of r, theta and phi, okay. So already I have discussed that theta you can change from 0 to pi, so that you will get the whole sphere. Phi you can change from 0 to twice pi, so that you can get the whole sphere. Then r also you can change from 0 to infinity. Now your question is, what do you mean by infinity? Infinity, for a plane surface, your r is infinite. So at the outside surface you can consider r is equal to infinity. At the center r is 0, at the outside surface this is infinity, because at that point this will be a plane only. For a flat surface the r is infinity, okay. So we have understood what r is, what theta is, and what phi is in terms of sphere, okay. Now you can tell your friend that when you cut an apple, that you are eating a phi or eating a theta, okay. Now we will extend this part towards the spherical polar coordinate system. Now let us try to represent it. So this is the sphere. You draw it, a sphere. Okay. So if you consider any point here like this, say this is suppose rho, then this angle will be your phi, that angle. We have represented this angle. Okay, this angle is your phi, this part is your phi. Then you draw a perpendicular here. This is your x-axis, this is your y-axis, this is your z-axis. Now we are to transform this xyz into r theta phi. Okay, so if it is phi, then it is again perpendicular. Like your polar coordinate, you see the side which is attached to the angle theta was cos theta, which was opposite to that side theta was sin theta. So if it is r, then automatically I can write, or if it is rho, then I can write x is equal to rho cos phi. Same logic, you can draw this cos phi OAP, all this triangle. I am not going to repeat this. So this side will be rho cos phi, like your polar coordinate, and this y side will be simply y axis will be rho sin phi. Okay. Now to represent a point in the 3D system, you again draw a perpendicular here. So this side you parallel, you draw a line, this is again will be perpendicular 90 degree. Then if it is r, okay, then this is your theta. This part is your theta, as I have shown it, that this part is your theta, this angle. So you can visualize if I draw the slices. These are the slices. This is the xy plane. Okay, in 3D this is the xy plane. So this plane is here like this, and the point P, this point is here. So this is P point and this is P dash. Okay, this side is I will consider as the arc. Now what you can do, this again, this is perpendicular, so you consider cos theta. This is OP, this is a C. Okay, so automatically OC is equal to OP cos theta. So OP is equal to R, so I can write R cos theta. So this OC is what? Along Z, so I will get one coordinate is Z R cos theta. Okay, Z is equal to R cos theta. This side is rho, so this side will be also rho. Now if it is perpendicular, then you see rho is equal to, that means PC is equal to rho, rho is equal to, I can consider OP sin theta. OP means R, R sin theta. Same thing, I am just extending this polar part. Once you understand polar coordinate, just extend to z-axis, you will get the 3D spherical polar, and you have to visualize the theta and phi only, nothing else. So rho you have got R sin theta. Here what you got, x is equal to rho cos phi, already you got it. Again rho you have got R sin theta, so this will be x is equal to R sin theta cos phi. Okay, and y is equal to rho sin phi, so I will write here y is equal to rho sin phi. So rho is equal to again R sin theta, so R sin theta sin phi. So what you have got? You have got x is equal to r cos theta, y is equal to r sin theta sin phi, and z is equal to r, sorry, x is equal to r, this is z is equal to r cos theta, and x is equal to r sin theta cos phi. This part r sin theta cos phi, this is x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. In physics we have used this r theta phi symbol. In mathematics some people use r phi theta also. So the definition of polar and azimuthal will depend upon how you have considered the coordinate system. We mainly use in physics r theta phi coordinate system. In that, how can you define now this r, this point P, when it is at a distance of r from the origin? Okay, so r is the distance from the origin towards the point considered. Okay, then this theta, this is the angle made from the z axis towards this r. Then what is phi? It is the projection of this point in the xy plane and the angle made from the x axis. So if you consider this, then this will be your in the anti-clockwise direction, this theta will be in the clockwise direction. Now changing theta, you will get the whole sphere, as I told you. Changing phi, you can get the whole sphere. Changing r, you can get the whole sphere. Hope you have understood the picture, you have understood the spherical polar coordinate and how you can transform from spherical polar coordinate to Cartesian coordinate system. Okay, so in the next video